After this, let's talk about Earth's magnetism. When we did start magnetic effect of current, we did talk about that when a bar magnet is freely suspended, like this, it always get stabilized in a particular direction, north and south, right? What does it mean? Why not east and west? So what is the reason behind that? So up till now it is considered that inside the earth there is a small magnet whose poles are just opposite to this, so they attract. That's why they get stabilized in the north-south direction, right? That's how we use that as a lodestone to find out the direction in the navigation, right? So question arises, if it is earth and we are considering a small magnet, we'll discuss it later on, but in chemistry you might have read Curie's temperature. When we increase the temperature of a ferromagnetic substance, then at a certain temperature what happens? Ferromagnetic substances lose their magnetic characteristic and ferro get converted into paramagnetic substance, right? We'll discuss it later on. So if the situation is like that, inside the earth the whole metals are in liquid form, right? And liquid form means their temperature is always greater than the Curie temperature. So means they can't have magnetic characteristic inside the earth. So this theory is not considered, becomes invalid. Later on they try to establish the relation with the solar current. Solar current is coming here and there to produce magnetic field, right? But it is still a question that how the earth has got a magnet, right? You might have heard Bermuda Triangle. The same situation is there. There is a very high magnetic, so whatever metallic body comes in contact or inside it, it simply engulfs it. That is called Bermuda Triangle, right? They are establishing different theory, but still today what we consider is the solar current does exist a bit, right? Now if earth is having a magnetic field of its own, what will be its different component? That's what we want to talk about, right? Suppose I am having a earth. This is magnetic north, this is geographical north and geographical south, NGO and SGO, right? If I cut a vertical plane by joining these two lines, these two poles, I will get a slice like this, right? This is known as geographical meridian, right? A vertical plane cut by joining the geographical north and geographical south, right? Same way, this is magnetic north and magnetic south. If a vertical plane is cut by joining these two, again a vertical plane will be obtained, that will be known as magnetic meridian, right? Now if I represent these two in a three-dimensional system, what I will get, right? Slice like this. Now I'm having, and another one, two pages of a copy, you could say, or a book, right? This one represent geographical meridian and this one is known as magnetic meridian. Right? angle between these two is alpha. This is angle of declination, right? And I am considering that there is a small magnet, so this will represent the magnetic field, BE, Earth's magnetic field. This is the horizontal component of horizontal axis of magnetic meridian, this one. So whatever angle the Earth's magnetic field form with this horizontal axis, this one, this is known as, theta is known as angle of dip, right? And if I divide componently, this is known as horizontal component H and this is known as vertical component V, right? H is the horizontal component of Earth's magnetic field and V is known as vertical component of Earth's magnetic field, right? These are the basic component of Earth's magnetic field. First is geographical meridian, second is magnetic meridian, then angle of declination, then we have angle of dip. This is the horizontal component and this is the vertical component, right? We will try to define one by one. Basic definitions. First of all, geographical meridian. What we have said, a vertical plane cut by joining the Earth's geographical north and geographical south, right? This plane. Second one is magnetic meridian. Again, a vertical plane cut by joining magnetic north and magnetic south. Third is angle of declination is the angle between geographical meridian and magnetic meridian. Alpha does vary from 12 to 17 degree, what I have read, but right, this is alpha. The most important one so far as your exam is concerned, the CBSE part, is angle of dip. It is the angle formed by the Earth's magnetic field with respect to horizontal axis of Earth's magnetic meridian. Remember, with respect to horizontal axis of the Earth's magnetic meridian, this one, right? The angle formed here is angle of dip, right? Do remember this one. Angle of dip at equator is 0. Angle of dip at pole is 90 degree. If you have any confusion, remember equator is the origin and started up to the pole, that is 90 degrees. So theta is 0 at equator and 90 at pole, right? Now the component of Earth's magnetic field. Earth's magnetic field is being represented by BE. Angle of dip, let it be theta, right? So what will be the horizontal component? Horizontal component of Earth's magnetic field is represented by H. H will be what? B cos theta. Remember the original component. Vertical component of Earth's magnetic field is represented by capital B. That will be BE sin theta, remember, right? And if you do it, you will find out BE square is equal to H square plus V square. Any BE can be calculated by simply having the under root of H square plus V square, right? And if you want to calculate theta by using this component, so what we have, V is B sin theta, H is B cos theta, right? So V via H will remain tan theta, B will cancel, so we left with tan theta. So angle of dip can be calculated as tan inverse V via H, or directly with this formula also. This is how we calculate the angle of dip, right? Now what will be the value of B and H at pole? Look, first at equator, right? What I have given you, angle of dip at equator is 0, theta is 0. So what will be H? H will be B cos 0, means V. What about H? V. B will be B sin 0, sin 0, 0, 0. So means at equator only the horizontal component will survive, right? At pole, what we have, angle of dip is 90 degree. So what will be H? BE cos 90, cos 90 is 0, so it is 0. V is BE sin 90 is 1, so BE means at pole only the vertical component will survive. Right? Like this you can calculate value of B, H, BE and theta. Right? Thank you and have a nice day, and keep on subscribing our channel if you want us to continue it further.